Hi everyone, I'm Finlay. I'm part of Safe Landing. We're a group of aviation workers all around the world in different parts of the sector, really keen to rapidly reduce the climate impact of our industry. So with that context, really excited to have Brian here with me. Good morning, Brian.
Good morning.
So Brian is Chief Sustainability Officer at Boeing, so really significant aviation company, really important role around sustainability. So really interested to get some of your thoughts, particularly about the future of air travel. But yeah, quite keen to take a bit of a flight through your life. So if we start off by actually rolling back 25 years, give us a bit of a background to how you first got into aviation, what interested you about that and sustainability in particular.
Perfect. Well, thanks for having me on. It's exciting to be here. Look, 25 years ago, almost with a couple months apart, I started at Boeing as an intern. If you go 25 years before that, I was born and raised in Belgium, and to a Belgian mom and an American dad. Didn't grow up with my dad, so I had these American roots and an American passport, but I didn't speak the language and had never been.
Very international, and the 25-year segments went very well for your life.
And so at the age of 16, I asked my mom if I could become an exchange student to the United States. So my first transatlantic or international flight was to America, and so it really sort of implanted the idea of aviation making the world literally a smaller place, and I'm in many ways a product of that. And so went to school in the United States, went to high school, liked it a lot, went to undergrad, got my MBA. And then the big Boeing Company came to campus, and I started in finance, but then very quickly got into business development, policy, government affairs. Moved 7 times for the company over those 24 and a half years now, 5 times across the Atlantic. So I've seen Boeing from far away, and I've worked at corporate headquarters in different roles, and really got to appreciate what it stands for. And I think that mission of connecting and protecting sounds like a slogan, but it's real. I mean, when you have a big defense portfolio, but also helped in many ways bring flight to where it is today, from a technology perspective, but also from a sustainability perspective, that inspires me. And if you just look at those 25 years, how far we've come. I mean, from the dawn of the jet age, again, 2 times 25, and you're an engineer yourself. 70% lower emissions, 90% lower noise. We've come a long way, but yes, we have a long way to go.
We had that kind of pioneering spirit in 50 years ago, and it's quite exciting to be thinking we're maybe on the cusp of that again. And maybe as young engineers, be living through another different type of jet era as well.
Exactly. Well, and look, in just 25 years, because you as an engineer know how long it takes to get these products to market. The safety certification regime, that it's second to none. The safety record of aviation is second to none. But in just those 25 years, we've brought the 787 to market, the 737 MAX, and we're a year or 2 away from the 777X. So we've renewed our fleet entirely. And so the step change improvement in efficiency that those airplanes deliver, in the 15 to 25% range, you get up to 30 depending on what you replace. There's a whole runway now of older airplanes that we get to renew with that latest generation.
And has sustainability always been something that has been in your mind and you're trying to orientate your career towards that? And has there been sort of more opportunities in that way across the industry?
For me, I started in business development and with a finance background.
Sure.
And then I got into policy. I got to work on Capitol Hill. I did a sabbatical because one of my bosses at the time said, "Hey, smart kid, you know a lot about, you're getting to know a lot about the aerospace sector, but the world really revolves around policy and smart policy." So he sent me on a sabbatical to Capitol Hill, where I got to learn a lot about, at the time, bipartisanship. And then I got to represent Boeing in Brussels and did 5 years there, leading government affairs in Europe. So it was business development, policy, and then more recently I spent a bit of time in communications, in corporate communications and positioning. And so what I really liked about when we stood up, and Chris Raymond was our first ever chief sustainability officer, and I was sort of employee number 2 working for him. It really pulls on all those 3. It's a lot of this is creative partnerships and new business. If you think about sustainable aviation fuels or carbon removals, those are new partnerships that we're developing. It's a lot about smart policy, and we have a global team in 13 countries that is informing regulators and policymakers what smart policy might look like. And then it is about sitting down and explaining how far we've come and where we need to go.
That policy point is a really important point because it's quite easy to get excited about new technology
Yeah.
and the shiny new thing that's going to come along. And actually, like, policy is often a driver of technology.
Yeah.
It shouldn't maybe dictate what the technology is, but it sets the guide rails and the direction
Yeah.
that allows you to innovate.
Yeah.
But it's quite difficult to get people excited about policy, and for that to come across as kind of as glamorous and as interesting.
Yeah.
And I think we're missing something there, because I think innovative policy can lead to innovative
Yeah.
business practices and technologies.
Yeah, and you got to make it less theoretical, and you got to zoom out. And if you look at the benefits of aviation, right, the 4.3% of global GDP that depend on aviation, the 87 million jobs, and I said 4.3, that's globally. In the Middle East, that number is 12%. Just talked to some friends in New Zealand, that's 16%. So when you all of a sudden have the entire economy depend on aviation, but a good chunk of it does.
Amount, yeah.
And regulators appreciate that it is about growth. It is about connectivity. It is about jobs of the future. It's about STEM. I mean, if you look in this room right there, half the room is young engineers, like what presumably inspired you to get into this business. So I think it's also our job to demystify this topic a little bit and explain that this is an exciting industry to get into. It is a growing industry, but we have our a huge responsibility to keep coming down that curve of emissions.
So great. So stepping into the present day and that all the stuff we do, obviously within Boeing, there's going to be thousands of different things going on at the same time. So maybe a bit of a difficult task, but what's like some topics you'd like to highlight in particular, projects that you're involved with that you'd like to get across you're working on today?
Yeah, let me talk about three things. Our journey on sustainable aviation fuels, what we do above and beyond SAF, and then this total climate impact model called Cascade that we've developed. So on SAF, we've been working from literally the first day, the first flight in 2008 on making SAF a reality. And that's been a long journey. And again, it's all perspective, but 2008 isn't that long ago. And from what was a bit of an obscure acronym is now in everybody's mouth. And everybody understands the opportunity that more sustainable fuels provide. And just in the last couple of years, if you look at the number of offtake agreements and commitments by airlines to fly on SAF, which I think your audience knows, it's a sustainable fuels made from different pathways, 7 approved, many more in the pipeline, feedstock ranging from bio-waste to municipal solid waste, gasification, et cetera. So many more pathways in the pipeline. But we were the company that first flew it, and then we were the first to fly on 100% SAF to prove that that is a reality. Again, well ahead of supply meeting that demand, but technically speaking, which is what our main role is, making sure that the airplane is capable of flying on 100% SAF. We did that first on a freighter with FedEx in 2018. We did that on a passenger flight with United in the United States. Recently, Flight 100 with Virgin across the Atlantic. So making sure that it's demonstrable, demonstrated as safe and certifiable.
And you're doing some work at the moment looking around the world at feedstocks as well.
We do.
Where those might be coming from, right?
Yeah, we've been doing this for some time, and because it's also a recognition, it gets back to policy, it's not a one-size-fits-all. The technology has to be safe, and is. But then scaling the production will benefit from different policy approaches, and we can talk about those, but also from different feedstocks. So we did a study with SMBC, Aviation Capital, and ICF in Japan, and what feedstock, and in that case, municipal solid waste and the gasification, might lend itself to SAF production because they don't have the real estate for big agricultural waste, if you will. Whereas in the United States, there are cover crops and ethanol looking for a new home as the ground electrifies, where that pathway is real and gets incentivized. So making sure that we look at the sustainability, the S in SAF, because that's what it's all about. It has to be sustainable. So indirect land use change, the socioeconomic sides of this, all get considered in the context of, for instance, the Roundtable for Sustainable Biomaterials has sort of your 12-point check box where you look at each of the criteria to make sure that there is an S in SAF. And so we as Boeing feel, after we've done the technology, making sure that we're a partner globally to help with feasibility studies, but then also in some cases working with Clear Sky and mobilizing financing to go into this important solution. So that's the SAF bucket.
Yeah.
Second is we call it SAF because SAF is foundational. We know that it's going to take SAF for at least half, probably 2/3 of the answer.
Yeah.
But then there's more to go, and we're a technology company in the end, and that's what excites us. So the is SAF and exploring how more electric architectures might earn their way safely into the airspace of tomorrow. We've been working a lot with hydrogen. 6 different demonstrators. We flew liquid hydrogen. We flew hydrogen fuel cells in demonstrators. Frankly, the more we look, the harder it seems. And it's probably something for the second half of the century, if at all. There's a big infrastructure challenge. There is just a physics question around if you had the abundance of green hydrogen, would you use it for a new energy carrier like that, or would you just make more SAF of it since it's a drop-in fuel? So there's some pretty good conversations going on there. But we're doing demonstrators like the electrified propulsion flight demonstrator with GE, a megawatt class hybrid electric engine getting installed in a Saab 340 to show, again, we're not going to decarbonize aviation with that, but we're going to demonstrate that, especially in the lower tiers, that for certain missions and for certain routes, a more electric architecture makes sense.
Yeah. Start building up those technology building blocks.
The building blocks,
maybe plug into the next product at some point.
Yeah.
Absolutely. Yeah. So what's your third one?
Well, the third was Cascade, and it excites us because it really brings it all together. A couple of years ago, we felt that the conversation wasn't complete in many ways, and not least because the conversations also around hydrogen didn't take into consideration the total climate impact of these energy carriers. Right? If you have an electric, I mean, in your house, if you have an electric vehicle and you plug it in, and you have a coal powered grid that's recharging your EV, the total climate impact of your electric vehicle isn't great. But if you have renewable electricity, you're fine. And so the same applies in aviation, right? Not all SAF is equal, and the emissions of SAF are equal. Gray hydrogen and green hydrogen are very different. And again, electricity matters. And so we wanted to have a tool that models and visualizes the complete impact of aviation, including its energy carriers. So we work with MIT, with our friends at the Whittle Lab in Cambridge, with NASA and IATA to look over our shoulders as we develop this initial tool, which is public at cascade.boeing.com, where you can really
you can move around the sliders,
you can move your own side, and you can make your own assumptions, but all bound in physics. And so I get to serve on the board of the Air Transport Action Group, ATAC, and for many in industry, Waypoint 2050 has been sort of the roadmap that shows how we will get to net zero 2050. And so think of Cascade as a dynamic model and that dynamic version of Waypoint.
Yeah, because there's so many scenarios within there, isn't there, that different directions we could go across. We recently had a talk from the Whittle Lab, and they quite nice in that they're like, we could go down scenario 1 where we put it all into a moonshot technology demonstrator. We could go for this particular type of SAF, contrail avoidance plans. There's not often roadmaps do tend to be a little bit like slightly clones of each other with small variations. But there's a lot of different, at the moment we're sort of standing at this crossroads where we could go in quite a few different directions, and we need to explore all of them and make sure that, then this next quite big investment we're going to have to make on the next aircraft or on the fuels.
And it's really been fascinating sitting down with policymakers, back to that conversation. Because think about the power to liquid sub mandate and Refuel EU. Noble in its sort of vision because it wants to stimulate investment in the latest and the most advanced technologies. But the amount of energy it'll take to produce these fuels is enormous. And so if you can show the trade-offs between power to liquid and maybe other architectures, I think it sort of visualizes for regulators what the policy's actually achieving or not. And it's just been, I think, a really healthy tool for us internally, but we made it available for everybody to play with and say, okay, what's my scenario that I believe in?
So like an aerospace engineer, whether you're at Boeing or another company, if you look at whatever's required, it's going to be resource intensive, energy intensive, and therefore also expensive compared to untaxed fossil fuel we can just tap out the ground. And that means that there has to be this focus on efficiency. It's almost like without question that the most efficient aircraft are going to be successful.
Yeah.
And that means a lot of engineering design and
Yeah.
development as well. So on that note,
Yeah.
just keen to get your thoughts. If we then fast forward 25 years, we're at 2050 or beyond. We've taken rapid climate action. We've transformed the aviation sector. What does that look like? How is it different,
Yeah.
and how is it better, both for kind of society, but also for aviation workers?
Yeah. Well, fortunately, we have a number of levers that we get to pull to get to net zero, and it starts with fleet renewal. I talked about the family of products that we're bringing to market. The penetration of those airplanes is only at about 25%, depending on which model we're talking about. But so there's still a good chunk of older airplanes that have to get renewed with newer ones. Operational efficiency, right? How we fly through the skies and how we leverage the digital brains in the cockpit to fly more efficient routes. The airplanes are far more capable than the airspace in which they operate. And so you look at the Eurocontrol statistics of 8 to 10% inefficiency today, just by the circuitous flying and the handoffs between ANSPs. We did a demonstration called a multi-regional trajectory-based operation, MRTBO, 4 countries between the US and then Japan, Singapore, Thailand, handing off the airplane in the most efficient route and anticipating the perfect flight, if you will. I mean, there's a significant improvement just by flying more efficiently. So leveraging the digital brains is the second. We talked about SAF and renewable energy carriers. And then the fourth really is advanced technology. And we're a technology company. That's what puts smiles on everybody's faces when they get to work on new, exciting stuff. I mentioned the EPFD we're doing with GE and NASA. The other one is X66, which is a transonic truss-braced wing. It'll put a smile on your face because we're creating a lot of real estate under the wing for a new and novel engine propulsion technology.
Yeah.
And so that's a flying demonstrator. That's not a scaled model or a paper drawing. That's going to fly. 2 XMD90s, one of which we're converting as we speak. So again, it's our job to keep investing and seeing which architectures of the future might be what's known to be pretty much the most efficient way of tube and wing flying. We just saw a presentation of one company looking at blended wing.
Yeah.
We also have, with Cranfield and others, have looked at the X-48B at the time with NASA. It's an interesting study. It didn't go to market the way we would have thought. And so we invested in the likes of the 787. But it's our job to keep investing in technology, and that's what we're doing.
Do you think that the truss-braced wing concept is a way of doing the tube and wing a little bit? It's quite a radical concept.
Yeah.
Aircraft they've been improving aerodynamically, bigger engines.
Yeah.
But it is a bit of a departure. And then the blended wing body is like a step beyond that because we're moving completely away. Do you think that we're more likely to see something like that at a sort of regional level first, middle of the market, or like long range?
We'll have to see. I mean, that's why we're testing it. That's why we're excited to be in partnership with NASA to just get the aerodynamics down and get the structure down, and then work with the engine companies to see what we can prove out. But again, you made us look back to make us look forward.
Yeah.
And with your background, we've always found ways to squeeze out even more efficiency out of various designs, whether it's the engines, the aerodynamics, how they all work together, and then we got the fuels to leverage. So I'm quite optimistic when I see the amount of energy and the passion that's going into it, and frankly, maybe where we started with that room full of engineering students. Again, presumably like yourself, getting into that space because you want to make a difference. Aviation is exciting. There's a lot of innovation that goes into it.
And that's a good segue for my final question, which is obviously we've got a lot of people in the group. They work in aviation. They might be in an airline, an aerospace manufacturer, air traffic control. So someone starting off in the industry in particular, they're keen to get into sustainability. What would be your advice about sort of what to get involved with, what to look for?
Yeah. Well, get engaged. Show up. I just took my 9-year-old. She just turned 10. One of my daughters to a SAF conference. Took her out of school for half a day, and she sat in the audience with me and got to talk and learn about SAF. You look at here in this region, the Royal Aeronautical Society, and sort of we've had programs there to inspire kids to get into designing, building, and then marketing their own airplanes. So I think whether it's at university level, different societies like the Royal Aerosoc, just get engaged, and then STEM is the foundation. So I think don't underestimate the importance of promoting STEM curricula and staying involved. And it's a bug. I think you caught it. I think many of your partners and members caught it. Aviation is an amazing industry to be in. I think it's a competitive industry. I think folks are very ambitious. Folks want to make a difference. So there's a reason I stuck with it now for almost a quarter of a century. We'll see where it takes us.
There's a lot of people that are dedicated. There's a lot of people that care. And yeah, it's great. So last thing I wanted to do, I'll just give you a safe landing lanyard.
Oh, fantastic.
Feel free to pass on to your daughter if she gets into aviation. Hopefully
wonderful.
She'll join one day. But yeah, real pleasure to talk to you.
Keep doing what you're doing. It's important to get aviation put in the right context, both it's the opportunities and the challenges, and I think you're doing that.
Thanks very much.
Well done.
And yeah, thanks for listening.
Thank you.